Hello and welcome to this second Crossing the Thames Estuary video in conjunction with Aves Marine, who are the UK distributors of ONWA products and in particular of the KM series of multifunctional displays. You will see all the different screens and you will also see the back of the display. This is because the KM series is about full chart plotter functionality, but also will provide for you flexibility to make choices, to expand functions, to be able to use existing or legacy equipment, integrate new equipment, and to allow all your systems to work together and independently. 3 data communication protocols drive the KM series: 0183 NMEA, 2000 NMEA, and now the new and currently unique OneNet NMEA protocol. Each protocol is used by the KM independently and without interference in order to provide very wide interoperability. This video is largely by animation. The next video will show you many of these opportunities in action. So let's start talking about the ONWA KM. If this was an 8-inch screen, it would be absolutely identical, except of course the size. There is a choice of 4 models in each size. First, the standard KM. This provides full functions of a chart plotter and 4 other screens. Model A adds full AIS operation to those. Model C adds depth, sonar and fish finder, but doesn't have the AIS. And finally, the top of the range Model X. This has AIS and full sonar. All models have a number of additional screens built in with the ready firmware for expansion. We will discuss all these options. Here is the standard KM12 model. Each model will look similar, either an 8-inch or a 12-inch or in each of the 4 models in each range. Note that with any model you get an inclusive external GPS antenna. You also get inclusive K-charts. These are built in by ONWA and you may find them really quite useful. Alternatively, you can get a CMAP or Navionics chart. They come on an SD card which you will place in the drawer of the KM and it will be immediately ready to upload. To do this, call up the plotter screen menu and open the dialog for the choice of the chart. Opt for the selected card and the KM will load it. Very simple. The KM remains on that selection until manually changed. There is one issue to note if you want to toggle between a third-party chart such as CMAP or to K-charts. You do the same selection on the plotter screen and then you go to the main menu and opt for the built-in chart in the map choice selection. The current chart displayed is a CMAP. With the standard chart plotting functionality, you get features such as timetables relating to wherever you are, and a celestial table. You can also record waypoints, routes, and destinations. You can even record on the chart using the drawing function. There are 4 standard screens in addition to the chart plotter screen. First, a compass screen. This is set up as heads up, but it could be north up if you wished, or other choices. Next, a navigation screen which shows latitude and longitude and the compass ticker tape at the top which centres on the heading of the boat. If you have an active waypoint, it's the bearing shown. You also have a highway screen. This is for use when you have an active waypoint to which you are going. When active, the screen will show the range and bearing to the waypoint and any cross-track error. And finally, you get full functionality with the satellite screen, which shows how many satellites are in view, the strength of those at any time, and the accuracy of the position. Built into the KM, you also get additional screens. These additions are built into the firmware, ready for use should you wish to upgrade your system. You can see highlighted top left the chart plotter. 2 icons along there is an additional screen, the screen of the wind direction and strength, true and apparent. Data fields include barometric pressure. The next additional screen is the AIS screen, then the sonar, depth and fish finder, then the radar. There is also an additional screen where the radar image is overlaid onto the chart plotter screen, and the final additional single screen which gives the instruments and gauges screen. To use those additional screens you need and can upgrade the standard system. Also built in is the choice of 5 split screens. These can be used with the standard chart plotter functionality as well as the additional screens if you have upgraded. There is a choice of 2, where the screen is halved, vertically or horizontally, 2 using 3 screens, and finally the 4 quarters that you can see here. Now let's get back talking about the 3 terminals at the back of the instrument and the flexibility of the KM series. First, we're talking about the 0183 NMEA protocol. This is the oldest protocol and is still very important. The first thing you could do is to add the wind data. Any wind transducer that exports 0183 NMEA data will serve, but illustrated is the ONWA KW360 Mini, which I use. It is particularly useful as it has no moving parts to mechanically fail. The wind transducer exports wind direction, strength and barometric pressure. This outputs 0183 NMEA data straight into the KM via the data port. The data is shown by both analog and digital displays. You can also add additional 0183 data if you have existing equipment that outputs the appropriate strings. One example could be when you have an existing depth transducer that outputs 0183 NMEA data. Simply connect the relevant cores of the transducer cable to the KM0183 NMEA cable. But this illustration is now using 2 separate 0183 NMEA feeds. 2 talkers want to speak electronically at the same time. 0183 NMEA needs discipline, which is why one of the reasons for introducing the 2000 NMEA protocol. For discipline, a multiplexer is required. You will see the multiplexer illustrated here, the ONWA KM 402. That can send 0183 data in both directions. A multiplexer is only required when 2 devices are trying to talk to or listen to the KM. One device can talk directly and listen to the KM without a multiplexer. Note, a pre-existing depth transducer that exports 0183 data will only provide basic depth reading, which might be fine for your requirement, but it won't get you the full sonar and fish finder screen unless there is an appropriate transducer, as you will see later. 0183 NMEA will also provide a valuable link two-way between an autopilot and the KM. This is the ONWA KAP, which I have and enjoy. The KAP includes a 9-axis electronic compass with GPS sensor and separate rudder feedback unit, and this will link into existing mechanical or hydraulic steering arrangements. If the two-way link is established, the KAP will follow waypoints, routes or destinations. Very powerful indeed. You will recall that I mentioned that we had an instrument or gauges screen ready for use. This screen is one example of the use of the 2000 NMEA protocol, which is often well known as the 2K NMEA. If you have an engine with EVC or similar, it is possible to liven up the instrument gauge screen by using an interface with a 2K NMEA cabling system, which I will call the backbone. EVC is a term used by Volvo, who call it the electronic vessel control. Others may use other terms. But what they mean is an electronic brain that runs functions of the engine and the gearbox. One function of the EVC is that it will, with use of a simple interface, output sensor data. The N2K NMEA protocol is simpler to connect navigational equipment than the 1083, but it does need a bespoke cabling backbone compared to the standard 2-wire system used by 0183 NMEA. Options for the bespoke backbone are available and need not be too expensive. With the 2K backbone, the KM series will accept that data and enliven the instrument gauges screen. If you have an engine without an EVC or similar, there are devices on the market that digitalize analog sensors which will interface 2K NMEA into the backbone. That is one use of the 2K NMEA system. Let us now look at the third NMEA protocol, the most modern protocol, OneNet. ONWA are the only manufacturers who are currently offering this protocol on the market. The practical advantages of this is to be able to exchange data immensely more quickly and to be able to cope with much more and diverse data. How to communicate data between equipment is also so much simpler as it uses standard Ethernet terminals and cables. No complicated handshake or bespoke cabling is required. A point about flexibility. Many of us will have a range of quite usable and popular pieces of equipment of varying ages. The ONWA KM series provides all three protocols that can be used independently all at the same time. That gives us a lot of choice, particularly when progressively upgrading our boat. The simple menu structure enables us to opt for 0183, N2K, OneNet or the built-in systems, whether to inputting or outputting data. Here you will see I am using 0183 to input the GPS and heading. This is opting for use by the 9-axis electronic compass sensor. You can see that all three protocols can be exported. Their independence evidence, for example, by exporting AIS via 0183, N2K or OneNet. Now, while I've been talking, a second KM machine has arrived. Here is one use of the OneNet protocol. If I have the KM12 at the helm, I might want a second machine at the chart table or elsewhere below. The second machine can be a KM8 or a KM12. Indeed, the machine at the helm could be a KM8 or 12. With a second machine, just turning on with no connections, GPS sensors or anything, the screen will be there, but the data absent. Just simply plug in with an Ethernet cable from your main machine to the second machine. Note that a crossover adapter is necessary, but that is only a matter of a few pounds. Instantly, the main machine becomes a server, and the second machine becomes the client. The server sends a signal to the client, indeed the client reciprocates, and then the client gets the screen live without the client needing any ancillaries. You have total inter-operability, so you can change screens one to the other. The server can change screen, the client can change screen. Each machine works independently. If you choose not to use a second KM machine, you can actually use the same method to receive radar. With an ONWA radome, you can use the Ethernet cable in exactly the same way as you've seen. This doesn't need a crossover adapter and the connection will come live instantly. Of course, there is only one Ethernet terminal on the back of the KM. If you want to have the radar and also a client screen down below, you would need to have a router. The router doesn't need the crossover adapter because it has the technology built in to do the crossover. Connect the server KM to one port on the router, another from the radome, and then the third connection to the client KM. On those connections you will continue to have full radar functionality on the server and on the client. And you continue to have full independent operability on both server and the client. The server will accept the data from the radome and provide independent interoperability on both KM. You don't need to have a second GPS antenna on the client. You don't need to have a second wind transducer set up. You would be able instantly to see all three protocols currently operating separately and yet together not interfering with each other. Note that the client screen can be altered independently, as indeed the server machine can be changed at will without affecting the client. There is another option. If you require full sonar, depth and fish finder functionality, even with the standard KM, you could add a dual frequency transducer and an ONWA Sonar N. The Sonar N connects to the router and provides the system with full function of sonar, depth and fish finder. There is of course the issue of deciding whether or not to have a machine such as a KM12 or 8C. The KMC model has all the standard KM that we have discussed, but adds full sonar, depth and fish finder functionality. It would be a personal choice between the KMC at the outset or progressively adding functionality as time permits. Options might be well worth discussing with the distributors. There is more that we can add. We can add a monitor, a very simple cheap option. This could be a very simple colour monitor, £100 or indeed less. For this, all you need to do is to opt for the option for an HDMI terminal at ordering and a standard HDMI cable. Connect an HDMI cable from the terminal added at the back of the KM to the monitor. You will instantly receive a copy of the working image of the server. But there is yet more. Note the reverse of the router. This has Wi-Fi and this provides another option. The ONWA radome is fitted with Wi-Fi, so a Wi-Fi link can be established between the radome and the router to provide radar data into the KM server. That eliminates the necessity for physical cabling, and it can release an Ethernet port from the router for other use. There is also a serial port at the reverse of the router, which accepts a standard DIN9 connection. A serial port will accept 0183 NMEA data, so you could export that data from the KM server to the router. The router has Wi-Fi and can send such NMEA data to an appropriate machine, such for example as a tablet, laptop or an Android phone. Obviously you have to set up the NMEA output from the KM to the serial port. That's an issue of two wires and knowing the pins on the DIN9 plug, and you have to know what the tablet, laptop or Android wants to receive. All this leaves the issue of AIS with a standard KM model. You have an AIS screen built in with the firmware in the KM, but it has no transducer fitted. But you can add a separate transducer, such as the ONWA KS200 transceiver, often known as a transponder, and you will need a VHF antenna. The KS200 transceiver imports and exports AIS 0183 NMEA. If you're not already using the KM NMEA data port, the connection is a simple matter, about 2 pairs of wires. If the port is otherwise already occupied, you will need to use a multiplexer. By using a separate transceiver, you will get AIS on the plotter screen. There is of course another option. The KM Model A has AIS provided, and that uses Class B plus SOTDMA 5 watt power. This is the best technology like the KS200. You will need an appropriate VHF antenna for the Model A, otherwise it is ready to run. And the KM Model A has the same chart plotter functionality and options as a standard KM. A KM Model A will have sonar, depth and fish finder functionality added by using the Sonar N and the router option, or basic depth readings if you have access to a depth transducer which exports 0183 data. The KMX is the top of the range. You will see AIS and depth included on the standard chart plotter functionality and of course the 3 protocols. With the Model X you do not need a separate AIS transponder, that is built in, and you don't need the sonar N for depth. You need to get an AIS antenna, but in the UK market a dual frequency depth transducer is inclusive in Model X. So you have a decision about the choice of models. This is the last screen that shows the connections possible for the KM Model X. The standard KM can be expanded, but it might not be the best option for you. Adding the AIS of the Model A avoids a separate transponder and can add full sonar or depth readings by the options we've discussed. But that could be a good option for some. In a similar way, like the Model A, the Model C adds full depth sonar and fish finder capability, but not AIS. It could be added, as we've said. If you opt for the Model X, you get both. And of course, whether it is standard KM, Model A, C or X, you have the options for full use of all three NMEA protocols, 0183, 2K and OneNet. We hope this animation helps. It does take a while to tell, but that is just because the KM series has been designed to provide as many options as possible.